The first mass has 10 oscillations in 2.76 seconds. So if I divide both sides by 10, I get 1 oscillation in 0.276 seconds. And the time to do 1 oscillation is the period. So that's t. So we want to find what k is of the spring, because that's going to stay the same for both springs, or for both masses. So t is equal to 2 pi square root of m over k. If I square both sides, that's t squared is equal to 4 pi squared m divided by k. And k is equal to 4 pi squared m over t squared. If I plug that in, our mass was 2 kilograms. We have 4 pi squared times 2 divided by 0.276 squared. That ends up being 1037 newtons per meter. All right, our second mass. We know that k is equal to 1037 newtons per meter, because that's going to stay the same. The period is the time for 1 oscillation. They tell us 10 oscillations happen in 3.24 seconds. So if we divide that by 10, that gives us 0.324 seconds, and we are looking for m. So we still have t is equal to 2 pi times the square root of m over k. Square both sides, gives us t squared is equal to 4 pi squared m over k. And if we solve that for m, that's going to be that is going to be t squared k divided by 4 pi squared. So plugging that in, that's 0.324 squared k is the same value that we had before, so that's going to be 1037 newtons per meter, and we're going to divide that by 4 pi squared. Now, even though you and I know that the 4 is attached to the pi squared, our calculators don't. So when you put this into your calculator to avoid order of operations problems, you want to make sure you have that in parentheses. And when all is said and done, you end up with 2.76 kilograms.